Okay, now you may not be a sports fan, and that's fine. What I want you to concentrate on here is how we're using the matrices to organize data, to organize information, and also matrix operations to make statistical analysis easy. Because you could translate this to anything with data, not just sports. So here we go. Matrices F and S give the points scored, number of rebounds, and minutes played for the starting five in a 2-game basketball tournament. So we have our first matrix here. I'm not going to read off all this for you. Points columns would represent points scored. First column, second column rebounds, third column minutes, and then starting five corresponding to rows. So Hurd in the first game scored 21 points, had 5 rebounds, and played for 35 minutes. Okay, yeah, just to make sure you're reading it correctly, how many rebounds did Dwayne have in the second game? There you go, right? Now that you understand that, let's do a couple of operations. Or let's just talk about the first one, because this would be torture for us to actually do it. It wouldn't be torture. I think that's a little overstatement, but it would be boring. So let's just symbolically represent this. Find the matrix that gives the totals for the tournament in each category. What would that be symbolically using F and S? Find the matrix that gives the totals for the tournament in each category. What would that be? What operation? So symbolically, you would just say F plus S, right? And then, add entry-wise, and you'd have a single matrix giving you the totals for both games. Okay, that's not the interesting example. Here's the more interesting example. So this is a matrix multiplication. I'm saying take the matrix, the row matrix, 1, 1, 1, 1, 1, 5 ones times F. Now, before we talk about it, let's write that down. If I write down the 5 ones, 1, 2, 3, 4, 5. So we're taking this matrix of ones times F, essentially. Is the multiplication defined? What's the order of the first matrix with ones in it? It's a one row, by 5 columns, right? What's the order of F? 5 rows by 3 columns. So you see these inner numbers match. So the multiplication is defined. All right, so I want you guys to do this. And once you see how to do it, it's not going to be hard to determine what this is going to give you. Some of you may already see what this gives you if you do this multiplication. I want you guys to try this multiplication. So since there's only one row in the left-hand matrix of ones, well, and you can look at the dimensions, can you predict for me what the dimension of the outcome is going to be? The order of the resulting matrix, what's that going to be? 1 by 3. So I want you guys to do that now. Just in your notes. So you're going to get the first entry, it's a 1 by 3 matrix, so your product matrix is only going to have one row with essentially 3 entries, 3 columns, 3 entries. So to get the first entry, you're going to take the row of ones and multiply it times the first column. And then you get the second entry, multiply times the second column, third entry, third column. Won't take you very long. And keep in mind what the columns represent. Points, rebounds, and minutes played. Points, rebounds, and minutes. And I want you to, first of all, calculate this and then tell me in a sentence what it really represents. Right? So give that a shot. So let's talk about this. Don't give me an interpretation yet. Just tell me what's the first entry going to be? And don't give me the actual number yet. What do you do to get it? Matrix multiplication wise, you would take what plus what plus what plus what plus what? Yeah. Essentially, by multiplying by a row with all ones times the first column, that's just going to have the effect of adding all the entries in the first column. Did everybody see that? Yeah. So you get 21 plus 18 plus 10 plus 8 plus 15. And then you can predict, oh, if I want the second entry, I multiply by that row of ones times the second entry. Again, I'm just going to be taking 1 times 5 plus 1 times 9 plus 1 times 7 plus 1 times 3 plus 1 times 12. Okay, and then third entry, same idea. You end up adding the 35 plus the 32 plus the 28 plus the 30 and squeeze it in here plus the 32. Everybody with me? And what do you end up with? 72. 157. Do I have confirmation? Okay. All right, well, that's all well and good if you can do the multiplication. What does it mean? What does this matrix represent? Yeah, so notice what the columns count stays the same, right? The category stays the same. And so the 72 is going to represent the total number of points scored by the starting 5 players, right? That's column 1. Column 2, 36, is the total number of rebounds by the starting 5. And then column 3, the total number of minutes played. So how would you summarize that? So the product represents the total number of points I'll say points scored, rebounds, and minutes played by the starting 5 in what? This was the F matrix, right? So the first game, in the first game. Proofread it. The product represents the total number of points scored, rebounds, and minutes played by the starting 5 in the first game. Yeah? All right, symbolically, could you tell? Oh, so by the way, let's back up. You may not care about this problem. I don't care about this problem. But what we're doing in this problem matters. The way this shows you how matrix multiplication can be used to manipulate and do statistical analysis on data, right? The data in this, again, you may not care about the particular data in this problem, and that's not the point. The point is you can analyze massive amounts of data by programming a computer to do this sort of multiplication on huge matrices. And data analysis is huge these days. You've heard of data mining, right? Well, you're being data mined as we speak, right? By big companies. And so far it's been pretty harmless. Will it always be harmless? I don't know. It's a scary future. But it's also an exciting future, right? And there's going to be many opportunities in statistics and data analysis. So if you kind of like this or you don't mind it, you know, you get a degree in statistics pretty easily. Well, okay, not easily, but it would take a couple years, and you could be an analyst. Do you guys know what an actuary does? They work for insurance companies. Well, it can be if it's life insurance, sure. But nobody knows, I mean, who's going to get in a car accident in here in the next 5 years, right? But you can make predictions based on data analysis, how many car accidents will occur per whatever number of people. And you can use that data to see how much you should charge for insurance, right? And then you charge that amount, and the insurance company makes money, and the insured gets covered. It's a win-win, right? All right.